Welcome to LabMinutes.com and our lab video series in Cisco ASA 1000V. You can find a complete list of ASA 1000V video on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. In our last video, we created security profile and security profile interfaces for our web and database servers with basic access list and NAT in ASDM mode via CLI. In this video, we will configure more advanced features on top of what we already have. This video is a counterpart of SEC0078 ASA 1000V Advanced Edge Security Profile and Policies VNMC mode. Here's our lab setup. We have a pair of redundant ASA 1000V installed in ASDM mode, with two security profiles configured for the web and database server. Some of the configurations that will be performed in this video is TCP Normalizer, Connection Timeout, IP Audit, Application Inspection, TCP Intercept, QoS Policing. And we will also modify the Ingress ACL on the outside interface that's currently having a permit all to only allow a TCP port 80 or HTTP to the web server, as well as TCP 2222 to our network management servers. In order to allow these web and NMS servers to be accessed from the outside, we need to create a one-to-one static NAT for each of these servers. For the web 1.32 will be NATed to the outside 128.32. For the web 2 will be NATed to a .33 IPs, and we will be configuring a port forwarding for the NMS server to forward port 2222 to the SSH port TCP22. We're still going to keep our catch-all port address translation to the outside interface at the bottom of the NAT table. Now let's get on to our CLI of our ASA 1000V. Right here, the first type of configuration we're going to be doing is for connection settings. This is going to do with the class map policy map. So first we are going to create a class map called any that will match, let's say, any traffic, so match any. Then we'll create a TCP or configure TCP Normalizer as part of TCP map, and we'll give it a name, TCP map. And here you can find a various of configuration that you can do to check the validity of the TCP protocol. So things like checksum verification, so you would do checksum verification, or you can check for exceed MSS, and let's say if the maximum segment size is exceeded, we want to drop the traffic. So you can spend time and look through some of these and see which one that you would like to turn on, but for us we're just going to do two of those. Now we get under the policy map, and since this policy map we plan to apply to the outside interface, we'll call it outside. And then to match the traffic, we use the class any that we created. First, we will start off with the TCP intercept. So with the question mark, you have an option to do set connection. And then you have various options that you can choose from. But for a TCP intercept feature, we're dealing with embryonic or half open connection. So first we do embryonic connection max. And let's say we only want to allow 512 maximum of embryonic connection. And for per client max, we want to limit them down to, and this is actually maximum connection per client, we'll say 1024, but for per client embryonic max, we want to only allow 128. And then at the end, you can also specify if you want to turn on random sequence number. And some of the application might not like it, as the sequence number and the TCP gets modified or randomized by the ASA, so you might want to disable that like we're doing it here. Okay, next we're going to look at the set connection timeout. Let's see what kind of timeout value we can specify. So things like embryonic, so how long you want to keep the embryonic sessions around for. You can see the default it's set is 30 seconds, so let's half that value and give it 15 seconds. And also let's specify a half close, which default is 10 minutes. Maybe you think it's too long, so let's make it 5 minutes, for example. And I think 5 minutes is also a minimum of that, so enter. So those are for the connection timeouts. Now we configure the TCP map for the TCP Normalizer. Now we need to specify that right here, so it can be enforced with the set connection advanced option, the question mark, and that will be the TCP map name. There's also an option for TCP state bypass if you're familiar with how you want to treat it as asymmetrical routing through the ASA, so you can basically tell the ASA to selectively ignore or perform a state bypass and not check the state table to allow the traffic that it might not see in both directions. So that's what TCP state bypass is for. Okay, so now if you show run policy map, and here's what configured so far. There's 3 sets of set connections, and now we need to apply that to the interface. So interface will be outside. Let's just do that, all those policies are enforced on all the traffic that is traversing the outside interface. That's just for the connection settings. Now we're going to move on and do IP audit features. Some of the config that you can do is fragment. This is basically you're telling ASA how to treat some of the fragment packets. So things like what is the maximum of fragments that you allow for a packet. Let's say it said right here default is 24. We're just going to choose 10. So we do not want to see a packet that has any more than 10 fragments, for example. And if you want to force reassembly as well, then you do fragment reassembly full. Okay, now we're going to move on to the IP audit command. And here first you need to create a name. By default, all the signatures are enabled. So if you do audit signature, you can pick and choose the signature ID, and you can disable them individually. Otherwise, they're all enabled. So first we need to create a name, and let's call this one outside. There's 2 types of category, attack and informational. So let's configure one for attack, and for the action, we might want to drop packets. So anything that's considered as part of the attack type of signature, or match the attack type signature, we want to drop it. And then you also have to specify how you want to treat the informational type signature as well. And for that, we might just want to receive an alert, so we choose alarm. When we have those configured, now we have to apply to the interface. So interface, again, we're going to do the outside interface, so outside attack, and then we have to also apply the outside info. So if you do show run IP audit, or actually show run pipe include IP audit, you see all these 4 commands in there. Okay, so we have essentially enabled IPS features on the outside interface with all of the default signatures enabled. Okay, the next thing we're going to deal with is the NAT for some of our web server and NMS servers that we want to be allowed access from the outside. So let's see what we have so far. What we have so far is a twice NAT or PAT that we placed specifically in section 3. So here we're going to do one-to-one NAT. We're going to choose section 2 for this, which is object NAT. So the syntax for that, object network NAT. And we'll start off with web 1. We're going to NAT that to a 128.32. And the host IP is 10.0.1.32. And then NAT. This is part of the web security profile. We have to specify the web interface. It's going to be type static out to 128.32 with DNS. Then we're going to repeat the configuration for 33, host 33, and NAT web outside static 33. Okay, the last type of NAT that we want to configure is port forwarding for the NMS. We're going to forwarding TCP 2222 to 22. Okay, and the syntax for that is, again, we're going to use object NAT for that. NAT, give it the name 128.16, which is the ASA outside interface, and we specify TCP 2222. And this is for the host of NMS IP, which is 1.16. NAT is from web to outside, static to interface. But since we're doing a port forwarding or service, so let's specify service, TCP for the real TCP port is SSH to a 2222. Okay, so if you do show run NAT, you will see all that in here. Okay, so that should be it for the NAT. Next, we're going to move on to the application inspection. If you do show run policy map, so you can see by default global policy has a whole lot of application inspection turned on. Let's say we just want to enable subset of that and apply it to each of the security policy. So we'll come up with a new policy map called, let's say, for Insight Web class. So you're going to have to choose inspection default, but instead of enabling the whole lot of inspect command, we're just going to choose certain application. So DNS, HTTP, let's say ICMP, so we don't have to keep allowing ICMP reply. So ASA can track the state of ICMP. We've got FTP and also TFTP because they both use a dynamic data connection. Now for the policy map, I'm going to create another one for a database. Security policy, again specify class inspection, and all we want to inspect for this guy is inspect ICMP. Okay, now what we can do is apply the policy map to those security profile interface. So inside map to interface web, and then inside DB to interface DB. Okay, so by doing that, that should override the global policy map for the application inspection. Next, we're going to move on to the QoS, which is something that we can't really find on the VNMC web interface. And we're going to do a simple policing for our ICMP. So first we need to create a access list for traffic matching. So access list ICMP permit ICMP any. And then for class map, we'll name it ICMP, and then we're going to match it with access list ICMP. Then we have to create a policy map for that, and we are going to apply that to the inside of the database interface. So we're going to use the existing policy map inside DB. And then for class map ICMP, we are going to, let's see what the other options that we have as far as, actually it's class, not class map. Class ICMP. And the option that you have is police or priority. If you want to put that in the allow queue for queuing, we can use priority, but we said we want to do policing here. So we're going to do police input, since it's going to be ingress to the DB interface, and then specify the rate. Just going to keep it at minimum of 8,000 bit per second. The last item we want to configure is modifying Ingress ACL on the outside interface of the ASA that's currently permit all. So if you do show access list from outside, you can see right now it's permit IP any. We just want to lock it down to the services of HTTP to the web and TCP 2222 to NMS. So we get under access list from outside permit TCP any. Actually, let's create an object group to make it a little easier for us. So object group network obj web SRV for server. Since both of our web server has contiguous IP, we're going to do .255.254. Let's make sure you got that right. Object group, so 1/ looks like that's wrong right there. So take that out and do that again. It's great. It's good that we checked. So 10.0.1.32, 255.255.255.254. Let's check it one more time. Just make sure there's no mistake. All right, that looks good. And now we can configure our access list. So access list from outside permit TCP any object group, call obj web SRV and equal HTTP or 80. And then we have to also allow TCP any to a host 10.0.116. Again, it's going to be the real IP, not the mapped IP of the NMS server, equal 22. And again, also real port and not the map port. And then we're going to finish it off with deny all at the bottom. So deny IP any log, and then let's do show run access list from outside, and we want to make sure we remove the original permit IP any. Okay, save. Okay, so now let's start with our testing. So first we'll get on to our web 1 and just do a basic ping to ASA inside interface, and that is certainly pingable. If you ping to web 2, which is .33, that is also pingable. We are next going to ping the next hop upstream switch, and I would like to enable or debug IP MCMP so we can see the source IP that's hitting the switch, just to verify that our NAT configuration is working. So we can ping 16.128.1, You can see that is succeeding as well. And if you go back to the switch in the background here, now it's showing up with 128.32, which is a one-to-one NAT IP. And just to note that since we took away the permit IP any from the outside ingress, and the fact that we are getting ICMP reply, that means our inspect ICMP or ICMP inspection is working because it's dynamically allowed the reply or ICMP reply. And you can also try to ping internet, and we have no problem. So Web 1 and Web 2 should behave pretty much the same way. So I'm going to skip Web 2 and then next try the database server or DB1 right here, and we're still going to ping 128.1, which is again the upstream next hop switch. You can see since we did not really make any modification to our NAT for DB security profile, it's still using the pat statement that we configured to the .18 in the previous video. Okay, we can also try to ping just to see if we can test our policing. We're just going to increase the size of the packet maybe to like 1,000. You can obviously see something's going on since we're not getting anything back. We can try 500 and see if that's any help. So 500 is going through. We'll take a look at the output of the show service profile in a second, but just to know that 1,000 is not letting through. Alright, so that is for DB. Next we're going to try from the NMS. So NMS, we can also try to ping the next hop upstream switch. And since NMS does not have or only have the port forwarding, it's still for the outbound traffic utilizing the path that we left intact on the NAT table, which is patted the traffic to the ASA outside interface of .16. Alright, so we pretty much tested all the outbound traffic. Now we're going to test the inbound. And from this machine right here, which is sitting at the VLAN 32, we're going to try to access the web server and NMS from the outside. So let's bring up the command line. First we start off with a ping to 172.16.128.32. Have that going. We'll hop onto the ASA real quick and do show log. Since we did not specifically deny any inbound ICMP requests, you can see it's getting denied by the outside access list. From outside, deny ICMP coming from 32.40 going towards 1.32. And it also says the first hit. Now let's try the traffic that is actually allowed, which is the web traffic to 16.128.32. You can see we can successfully hit the web page on the web server 1, change to 33. You can see we can also hit the web server 2. And another service we need to test is the TCP to 2222. So we can bring up, let's say, PuTTY, and then we'll use 16.128.16. We use SSH and port 2222 open. You can see we immediately get a login prompt, and we can successfully log into the SSH session of the NMS server. Again, just to prove that, you can do show connection, and right here you can see 32.40 tries to talk to 1.16 on port 22. Okay, so now that we have performed all of our testing, let's go back to the ASA and do some of the show commands and see if we can see some of the hits to our policy. So first start off with the service policy on the interface web. And if you remember, we have a QoS attached to that, as well as some of the ICMP inspect. Actually, for the web, we just have the, I think, application inspection. It's actually the DB that we have the QoS. So that's why we look at the web here, we only see application inspection. And you can see we have inspect HTTP. This is when we try to access the web server from the outside. We also have the ICMP inspected packet as well. Okay, next we're going to look at the DB. This is where we have both inspection and QoS. So right here, inspect ICMP, we got 28 packets. And on the QoS policing side, we got 7 conform packets, although we didn't really have any drops or exceed packets or anything. Okay, next we're going to look at the interface outside. It's a little bit more elaborate here. So from the top, you got class map that match all the traffic with the embryonic, although we didn't really test embryonic, or at least it tells you there's a current connection. One which I believe is still our SSH session right here. And if there's any abnormality in the TCP protocol, it should report right here as well, assuming you have all those detection enabled. And here also is also shown the timeout policies for the embryonic and half close. Okay, so let's take a look at the show access list from outside. Here for the web servers, there's been 3 hit counts. Okay, so we know that because we got a successful page loaded from our test machine on the outside, and also we have 1 hit count for our port forwarding to the NMS server. And here we got 4 hit count for the ICMP request that we did to the web server, and that was being denied. Okay, the last show command we're going to do is show IP audit count. And here we apply the IP audit to the outside interface, and you can see it detected some echo reply and echo request. Here, interestingly, we also see some large ICMP, and I guess this is when we're trying to ping with the size of 1,000, and that was being dropped on the DB1 server right here. Let's try it again with 1,000. You can see it's not getting through, and let's take another look. Before, this counter was sitting at 8, and now it went up to 11. And clearly the large ICMP signatures on the ASA was dropping that packet, and that's the reason why the ping did not go through initially. So you can see when you configure ASA 1000V in an ASDM mode, there's a lot more available features and commands that you can do, and QoS is one good example of that. But again, when you're in SDM mode, you have to configure these ASA individually instead of leveraging the fact that you can reuse the policies when you configure the ASA in the VNMC mode. So there's pros and cons in both methods. So this pretty much wraps up our video on ASA 1000V Advanced Security Profile in SDM mode using CLI. You can visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.